All right, ladies and gentlemen, so here's a practice test. So select the most specific name for the quadrilateral shown. All right, we see that four sides are congruent. We don't see any right angles anywhere. So the best one there is a rhombus. So again, all four sides were congruent. All right, the second one states determine the value of x in the diagram. Well, again, they're telling us that those two are the same. All right, so then these two have to be the same to make it a parallelogram. So opposite angles are congruent. So then we know x has to equal 84. And I would say, ladies and gentlemen, just to make sure, if you can put the degree symbol there, it doesn't show it, but well, maybe they wouldn't need it because it's up here. Guess we'll see. Either way, if you put the right answer, I would give it to you. All right. Okay, let's see. Number 3 states find the value of x in the diagram. Remember the sum of the exterior angles. Is always equal to 360 degrees. So we know that we have x plus 2x plus x plus 2x is equal to 360 degrees. Add all of those x's up, we get 6x is equal to 360 degrees. When we divide by 6, we'll get that x is equal to 60. Again, I'm not sure if they want you to put that there. I guess we'll find out. I guess I can find out when I look at your homework tonight. I'll give you guys a heads up on that. So number 4, find the coordinates of the intersection of the diagonals of parallelogram GHJK with vertices at 1 and 3. H is at 2 and 1. J is at -1 and -5. And K is at -2 and -3. So I kind of just drew a quick parallelogram. It doesn't have to be perfect. And I said that G was at 1 and 3. H is at 2 and 1. And as long as you have them in order, it doesn't really matter where you start, to be honest. It won't look good if you were on a coordinate plane, but on this one here, it's okay. So remember that the coordinates of the intersection is the midpoint. So if it's the midpoint, take the midpoint formula for one of them. So I went ahead and took the midpoint for that diagonal. All right. And then remember that is going to be, the midpoint is equal to the sum of the x's. So that'll be 1 plus -1 all over 2. And for the y's, it'll be 3 plus a -5 divided by 2. And if we work those out, 1 plus a -1 is 0. 0 divided by 2 is 0. 3 plus a -5 is -2. -2 divided by 2 is -1. So there is your answer. So you're going to tell me 0, and you're going to tell me -1. All right, so for some reason, this one always seems to be the hardest one, ladies and gentlemen. But again, just think of what you have to do. Take out a piece of graph paper if you have to. That would help you. So our points are at -1 and -1. We have another point at 1 and 4. And we have another one at 4 and 0. So here's my M. Here's my N. Here's my P. And since it's saying M, N, P, so if it's M, N, P, you know, Q is going to have to be in there somewhere. All right? Since you know it has to be somewhere around there, just go ahead and remember, since it's a parallelogram, take it and find the slope. Find this slope. Now, from what I'm told, it's not going to let you. It's not going to let you draw the line there. So that's why we suggest maybe use a piece of graph paper. But there's my line. Now, what is my slope there? What do I need to do to get there? So just think. If I go over to this direction to get to M, I'm going in the negative direction, right? And on this one here, I'm going down -5. All right? So you want to do the same one for this one here. So I'm going to go over -2, and I'm going to go down -5. And there's where Q will be. They're not going to tell you that you're just going to put the point there. You don't have to label them. So your Q in that case will be at 2 and -5. Number 6, given that line segment AE is congruent to line segment EC, for what value of X is the quadrilateral ABCD parallelogram? Now remember, we just talked about these here. So those two are congruent. And again, for it to be a parallelogram, these two also have to be congruent. So again, E there would be the midpoint, but again, it bisects it, it cuts it in half, so we can say that 4x is equal to 3x plus 1. So I'm going to subtract 3x on each side, and I'll get that x is equal to 1. Okay? On these ones here, it'd be a nice time to use that thing I gave you, that list of stuff. Okay? We know if the sides are congruent and parallel, we know that we can prove it is a parallelogram. All right? On these ones here, they're parallel, and these ones are congruent. But again, what did I just say with the other one? Parallel and congruent. On this one here, we don't know. So we are going to say cannot prove it is a parallelogram. And hey, this was just like the one above. All right, if the diagonals bisect each other, then we know that it is a parallelogram. Number 8, in quadrilateral EFGH, in the coordinate plane, the midpoint of EG is 2 and 2. What additional statement allows you to conclude that EFGH is a parallelogram? So again, just kind of think what I just told you. And here, this one here was also another one. Remember, for it to be a parallelogram, they both have to have the same midpoint. So if they both have to have the same midpoint, then we know that it has to be the midpoint of FH. Again, this one here, they told us this one has to be 2 and 2. Okay. On the Venn diagram here, show how the three. Use the Venn diagram to show how 3 quadrilaterals are related. So this is kind of like that one, but it's going from the smallest one to the largest one, right? So if we think about it, we can tell you that the largest one is a parallelogram. All right, now which other two are similar? Well, a rhombus and a rectangle and a rhombus and a square, but they have to have both of them. So you could tell me a rectangle is here, and we know if a rectangle is there, a square is a rectangle with all 4 sides congruent. So that is the way you should do that one. or something similar. Okay, just think about what I just did there. Okay. Let's say in the gemstone is the shape of a rhombus. Match the measures with the angles. So angle 1, remember with the rhombus, the diagonals are perpendicular to each other. So they're 90 degrees. Okay. Angles opposite are the same. So angles opposite are the same. All right. So that would be 65 there. And of course, diagonals bisect. So we know that one there also has to be 65. And then if you think about it here, this one here is also 90 degrees. And you can tell me that the sum of those is equal to 180. Or you can tell me that these two equal 90. All right, so if we know that, then this one here has to be 25 degrees. Not 250, 25 degrees. Okay. Trapezoid ABCD is a cross-section of a lampshade. The diagonals of trapezoid ABCD are congruent, and the measure of angle D is 71 degrees. What is the measure of angle B? So remember, the measure of angle B is equal to the measure of angle C because base angles are congruent. So if base angles are congruent, remember, the bases are also the ones that are parallel to each other. So if they're the ones parallel to each other, ladies and gentlemen, what am I making here? A backwards C. So that would mean that they are co-interior angles. Would you agree? And if they are co-interior angles, we know that the measure of angle C plus 71 is equal to 180. So if we subtract 71, we know that the measure of angle C is equal to 109 degrees. And since the measure of angle B is equal to the measure of angle C, they're asking us what B is. We can say that the measure of angle B is also equal to 109. And on this one here, they did put the degree symbol there. Okay. Number 12, find the measure of angle C. Write your answer as a decimal. So if we remember, this is a kite, and on the kite, two of the angles have to be the same. So let's call this one X and this one here X, because you know that they have to be the same, because we know that the measure of angle C is equal to the measure of angle A. All right, so if you think about that, I just said I have two X's there, plus 117 plus 70, and that is equal to 360 degrees, again, because it's a quadrilateral. So if that's the case, let's see, 2x plus 187 is equal to 360 degrees. I'm going to subtract 187. So I'll get that 2x is equal to 173 degrees. And I'll get that x is equal to, if I divide by 2, 86.5. And again, x, I just told you, was C. So we know that this has to be 86.5 degrees. 13, find the measures of the numbered angles in rhombus ABCD. So just like before, ladies and gentlemen, again, diagonals are perpendicular to each other. So if they are perpendicular to each other, remember, you don't have to start with one right away, okay? So we can say that the measure of angle 4 is equal to 90 degrees. And let's see, what else do we know? If that one here is 24, then we know that one there has to be 24, and that one has to be 24. Again, because they bisect each other and they're opposite each other. So we can say that this one here is 24, and this one here is 24. So that would mean, again, if you think about it, here's triangle here. So the measure of angle 1 is equal to 180 degrees minus the 90 degrees minus the 24 degrees. Or we could have just said, hey, these two here are complementary. So we could have just said the same thing. Well, you'll notice I still get 90, so 90 minus 24. And then I'll get that the measure angle 1 is 66 degrees. Okay. And then 14 says in rectangle QRST, QS is equal to 4x plus 9 and RT is equal to 6x minus 1. Find the lengths of the diagonals of QRST. So remember, if they are diagonals in the rectangle, we know that they are congruent. If they're congruent, we know that their measures are equal. So we can say that QS is equal to RT. So we can say that 4x plus 9 is equal to 6x minus 1. All right, I'm going to move that 4 over there, the 4x. So 6x minus 4x is 2x, minus 1 is equal to 9. I'm going to move the 1 over there. So now I'll get 2x is equal to 10. And then I'm going to divide by 2. So x is equal to 5. Now be careful. Here's where I keep telling you, you've got to read it every once in a while. They didn't ask us that. They asked us what the length of the diagonal is. So we have to plug it in there. All right? So if we plug it in there or there, it doesn't matter which one. I'll show you on both of them. Because RT is equal to 6. We just said x was 5, so 6 times 5 minus 1. Well, 6 times 5 is 30. Minus 1 is 29. And I'll just show you that QS is also the same, because I will have 4 times 5 plus 9. 4 times 5 is 20. 20 plus 9 is 29. So notice either one of them, I got 29 units. Let's see, 15, find the measure of each angle in the isosceles trapezoid. So remember, they're parallel. The isosceles just tells us that the two sides are the same length. All right. The two sides are the same length, then we know that the base angles are the same. So if A is at 136, you know that B is also at 136. And just like I showed you before, that makes a C there, right? So if the measure of angle D is equal to 180 minus 136, excuse me, and we'll get that the measure of angle D is equal to 44. So if D is 44, then C also has to be 44, and I just told you that B was 136. And again, just as a quick check, if you wanted to, they should add up to 360 degrees. And finally, the last one, the bases of a trapezoid have lengths of 10 feet and 22 feet. Find the length of the mid segment. Now, kind of think the mid segment, it sounds like midpoint. So if that's the case, the mid segment would be the sum of the two. So I'll have 10 plus 22. And I'm going to divide that by 2, which will give me 32 on top, divided by 2, which is equal to 16. So the length of the mid segment is 16 feet. All right, ladies and gentlemen, that's it. I would suggest you kind of follow this if you need to. I'm not saying you have to do every single one of them, but it doesn't hurt to watch it. Good luck tomorrow.